Hello everyone, we're looking at angle pairs again today. These are some new angle pairs that we have not studied yet before. We've studied other angle pairs like vertical angles, complementary and supplementary angles. So now we're going to learn 4 new angle pairs today, and we're going to look to see how they relate to each other. Alright, so first of all, in order to create these angle pairs, we're going to be drawing a transversal, and that's what we'll start off with. So a transversal is a line that intersects two or more coplanar lines. At different points. A transversal is a line that intersects two or more coplanar lines at different points. As always, a diagram helps here. So we want two or more lines. I'll draw 2, and if we're drawing an object, we should name it. So here's line L and here's line M. So here's 2 lines. We could have more than 2 lines. And a transversal is going to be another line that intersects those lines at different points. In other words, just kind of draw a line that crosses right over it. And I'll call that line T for transversal. So notice we have 2 points of intersection. And that's kind of what you see now in the diagrams below in the next 4 boxes. We have 2 lines with a slash through it, a transversal. Now, what you see happening here is we actually get 8 angles as a result of it. 1, 2, 3, 4, 5, 6, 7, 8. And in these next angle pairs that we're learning about, we're focusing on certain combinations of these 8 to see how they might relate. Okay? And so in the first one we're looking at here, they're numbering angles 2 and 6 as an example of this pair, but there are more than just 2 and 6. But what you observe here with the pattern is that angles 2 and 6 are both sort of in this top right hand corner. You can see that they're not the same size, but they are in the same relative position. So that if we're looking at the top line between these 4 angles here, we're looking at this top right hand corner. And if we're on the bottom line, again, between these 4 angles, we're looking at this top right hand corner. We call these corresponding. So 2 angles are corresponding. Corresponding angles if they have similar positions relative to the point of intersection. So we have 2 points of intersection, so we look at the top point of intersection and then we look at the bottom point of intersection and we look to see if they have a similar position. So angles 2 and 6 are examples where they have this position of being in the top right corner. Another example of a similar position would be if it was in the bottom right corner relative to that point of intersection. We could also have 2 that are in the bottom left corner relative to that point of intersection. Or we could have the top left corner. So each of those pairs, we get 4 of those combinations are corresponding angles. In this next case, we're looking at angles, 2 angles that are going to be in between the 2 lines, but one of the angles is on the right side of the transversal and the other angle is on the left side. So because they are on alternate sides of the transversal, these 2 angles are called alternate interior angles. Interior meaning they are inside the 2 lines. Out here would be exterior. In between is interior. So 2 angles are alternate interior angles if they lie between the 2 lines and on opposite sides of the transversal. So one's on one side, the other angle's on the other side of the transversal. So again, they are just numbering 4 and 5 as an example, but you could also have angles 3 and 6. That would be another pair of alternate interior angles. For the third pattern, we're looking now at angles that are on the outside. They are not between the two lines. One is above and one is below. So these are not interior angles. These are exterior angles. And again, you realize that one angle is on one side of the transversal and the other angle is on the other side of the transversal. So again, we have an alternate pair showing up again, but this time they're not alternate interior, they're alternate exterior. Two angles are alternate exterior angles if they lie outside the two lines and on opposite sides of the transversal. So again, this is just one example using angles 1 and 8 from the diagram, but we could also use angles 2 and 7. 2 and 7 would be another example of an alternate exterior pair. For the last pair that we're learning about today, notice that once again our angles are between the two lines. So again, this is an interior pair, and if you contrast these two diagrams, above we have alternate interior. These are not alternate because these two angles are on the same side. So we call them consecutive. Consecutive interior. Two angles are consecutive interior angles if they lie between the two lines and on the same side of the transversal. So this is the same side, and above that's the opposite side is where they lie. So when we're using consecutive in math, what we mean is one after the other. Think, for example, of your counting numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 are consecutive numbers. These are consecutive angles because if you travel from one location to the other, you get the next angle. Notice it's not the same as adjacent. We have studied an adjacent pair in the past. Adjacent angles have to have the same vertex and share a common side. For example, angle 2 and 4 are adjacent, but we would not necessarily call them consecutive because adjacent means they are in this particular pattern where they share a common vertex and share a common side. These angles then are not adjacent, they are consecutive, meaning they're sort of close to each other. It's one right after the other. There's no other angle showing up in between them, but they're not adjacent. Now we have to memorize these four. If you don't memorize them, it's going to be very difficult to be able to find them and to set up equations and solve for angle measures and to do some of the proofs that we'll be doing in the next few days. So let's start off by just practicing naming these angle pairs. Identify the following. It starts off with the transversal, and then it goes on and takes a look at all the different pairs. Now you'll notice that in the diagrams above, the two lines that we were drawing were running side to side, not exactly horizontal, but side to side. And notice that in this example that we're looking at here, the two lines that we're looking at are in fact running, maybe not exactly up and down, but they're not running side to side. So these are the two lines we're talking about. That means if we're looking at angles, we want to know, are the angles between the two lines, or are they outside of the two lines? That means R is the transversal. All right, so the first question is, what is the transversal? That's line R. Let's find all the pairs of corresponding angles. So corresponding angles, you could look up there to see what that is. Those are angles in similar positions. So what you want to do is find the 2 points of intersection, and then you want to travel in the same way. Let's go up and to the right. So that's a pair of corresponding angles, 2 and 4. So we would say angle 2 and angle 4. We're going to, again, go to the point of intersection, and we'll travel in the same direction. Let's go up and to the left. So if we go up and to the left, we have angles 1 and 3. Then from those points of intersection, if we go down and to the right, we end up here at 6 and 8. So angle 6 corresponds with angle 8. And then from the points of intersection, let's go down and to the left, we have 5 and 7. So we would say angle 5 corresponds with angle 7. Let's find pairs of alternate interior angles. Alright, so again, interior angles have to be between the two lines, so that means we're looking at angles that are between the two lines. So we're talking about angles 2 and 3 and 6 and 7. Those are interior angles that we will pick from. But alternate means they have to be on opposite sides of the transversal. So 2 is above the transversal, 3 is above the transversal, 6 and 7 are below it. Now we're not picking 2 and 6 as an example. Notice one's above, one's below. That's actually a linear pair, right? A linear pair are two adjacent angles that form a straight line. So we're not picking 2 and 6. No, we're picking 2 and 7. So one angle is on one line, the other angle is on the other line. One angle is above the transversal, one angle is below the transversal. So we say angle 2 and angle 7 are alternate interior angles. And then the other pair would be 3 and 6. So angle 3 and angle 6. Let's look at pairs of alternate exterior angles. So alternate exterior angles, exterior meaning they're on the outside. So we're looking at these 4 angles as possibilities. We're looking at angles 1 and 5, 4 and 8. Those are exterior angles. And we want them to be alternate. So again, we want one above the transversal and one below the transversal. So one pair is 4 and 5, the other pair is 1 and 8. Let's jot that down. So angle 1 and angle 8, angle 4 and angle 5 are those pairs of alternate exterior angles. Lastly, we want consecutive interior angles. So again, we're back to interior. That means between the two lines. So we're talking about angles 2, 3, 6, and 7 as being the interior angles. We want consecutive angles. So again, we don't want angles like 2 and 6. That would be a linear pair because they form a straight line. We want two angles that are touching the two lines. We want one angle touching line P and one angle touching line Q. If they were alternate angles, one angle would be above and one angle would be below. But because they're consecutive, they have to be on the same side. So we're talking about angles 2 and 3 as a pair of consecutive interior angles. One angle is touching line P, one angle is touching line Q, and they're both above the transversal. So angle 2 and 3 is an example. And then the other example is angle 6 and 7. Again, one angle touches line P, one angle touches line Q. Both angles are below, they're on the same side of the transversal. So to finish that off, angle 6 and angle 7. So you can see with corresponding angles there are 4 possible pairs, and with the other 3 types there's only 2 pairs to be found. So now we want to take a look at the relationship between them. We want to look at these angle pairs and ask questions like, are they the same size? Are they going to be complementary? Are they going to be supplementary? Is there anything we can find out? So we're going to explore that concept here on the next page. And I'll walk you through this, and we'll kind of talk about the properties as we go. So we're going to use a straight edge and a piece of tracing paper here as we just kind of casually compare the angles. We're not actually going to take their measures here. Let's use a straight edge to construct a pair of non-parallel lines intersected by a transversal. Alright, so here's one line, and here's another line. Alright, so they are not parallel. And then I want a transversal. And I like to give it a pretty sharp tilt so that it's easier to compare the sizes of these angles. Alright, so there's my transversal crossing over the two lines. Let's number off these angles. So angle 1, 2, 3, 4, 5, 6, 7, 8. That way we can compare various combinations of angles. So we did step 1, we did step 2, where we numbered off those angles 1 through 8. Step 3. Let's use tracing paper to copy one of the angles from a pair of corresponding angles. In other words, let's find a pair of corresponding angles to use, and let's compare their sizes. Move the tracing paper so the copied angle fits on top of the other angle in the pair. So first we have to find some corresponding angles. Remember, corresponding angles are angles in similar positions. So start at the point of intersection, and then you want to go in the same direction, like up and to the right. So here angle 2 and 6 would be corresponding angles. Or we could go up and to the left. So angle 1 and 5 are corresponding. So it doesn't really matter. Let's use 2 and 6. So just to kind of note which ones I'm looking at, I'm going to use angle 2 and angle 6 as an example. Instead of using a protractor to measure, we're just tracing those parts of the lines that form the angle, and there's angle 2, and then because angle 2 corresponds with angle 6, we're just informally comparing the sizes by putting angle 2 on top of angle 6 and just asking the question, do they have anything in common? Do they look to be the same size? And the answer is no, they don't. Angle 2 is a little bit bigger. So I would say that in explaining how the measures of these angles compare, they are not equal in measure. Now we don't have specific angle measures, so in a more general sense we would say they are not congruent. We're going to do the same thing with each of the pairs. So in step 4, we're going to look at a pair of alternate interior angles. Alright, so let's find a pair of alternate interior angles. So interior meaning we're looking at angles 3, 4, 5, and 6, and alternate meaning one angle's on the left side, one angle is on the right side of the transversal. So we can either use 3 and 6 or 4 and 5. It doesn't really matter. I'm going to use 3 and 6. So again, I'm using my tracing paper here and tracing over the sides of angle 3. Now if we want to put that on top of angle 6, it's pointed in the wrong direction, so we will have to rotate the angle around so the vertices line up, so as many of the sides line up as possible. And once again, angle 3 is a bit too big. There's angle 3 and there's angle 6, so angle 3 is certainly bigger than angle 3. So it would appear that when we compare the measures, they are not equal in measure, but we don't have actual measurements, so we would say they are not congruent. Let's try an example with an alternate exterior angle pair. So exterior angles means we're looking at angles 1 and 2, 7 and 8, as they are outside the two lines. Alternate meaning one's on the left, one's on the right. So I can use either angles 1 and 8 as a pair of alternate exterior angles, or 2 and 7. Let's use 1 and 8. So again, I'm just using my tracing paper to copy angle 1. There it is. And if we want to compare that with angle 8, again we'll have to rotate it around so that the vertices line up. Try to get a pair of sides lined up. And you can see that angle 8 is bigger. There's angle 8. It goes beyond the side of angle 1. So they're not the same size. So it seems so far that we have a pattern that these angle pairs, even though we have them by name, don't seem to have any special properties, because every time we keep getting the same result of not congruent. Last pair is the consecutive interior pair. So back to interior, that means we're looking at angles 3, 4, 5, and 6, and consecutive means they're on the same side. So we're pairing up angles 3 and 5, or angles 4 and 6. Let's do 3 and 5. Are they the same size? They don't look it to me. Angle 3 looks a whole lot smaller. So there's angle 3. And let's now put that here with angle 5. You can see that angle 3 is a whole lot smaller and angle 5 is much, much bigger. So how do their measures compare? Not congruent. I think we found a pattern. And then here's a follow-up question. This is interesting. Do those consecutive interior angles form a linear pair? That means could we put them adjacent to each other and form a straight line? So you can see how 5 and 6 form a straight line. That's a linear pair. If we put angle 3 right here, would they form a straight line? Would that be a linear pair? Let's find out. So there's my angle 3 again. And if I move it here to angle 5, you can see it's not the same size. But let's just spin that angle around so that what we're doing is we are sharing a common vertex and a common side. So here's angle 5. So there's angle 5. And then here's angle 3. And we want to know, do they form a straight line? And it's slightly bent right there. I don't know if you can see very well, but they do not form a straight line. It's a little bit bigger than 180 degrees. So no, they are not supplementary. No, they are not a linear pair. Okay, well, that was pretty conclusive. There is no pattern at all if this was our starting diagram where we had non-parallel lines. So let's make one small change. We're going to make a new diagram down here at the bottom where it says example 3. This time we're going to construct a pair of parallel lines. So if you have a ruler, don't move it, just hold it in place. Just trace the top side and the bottom side of the ruler, and that gives you instantly parallel lines. Again, I'll call them line L and M. And then for the transversal, again, give it a nice slant. Step 2, number the angles 1 through 8. So 1, 2, 3, 4, 5, 6, 7, 8. Now we're asking the exact same questions, and they're listed on the next page. We're asking the exact same questions as what we had done with the previous diagram. Let's look at each of these pairs. Let's look at corresponding pairs and see if they are congruent or not. So let's compare angle 2 with angle 6. So I'm tracing angle 2, and if we take that angle and we move it to angle 6, look at that, it appears to be congruent. So we'll put that answer in on the next page in just a moment. The next angle pair is alternate interior angles. So these are the interior angles. We want alternate, so that would be either 3 and 6 or 4 and 5. Let's do 4 and 5. Alright, so here is angle 4. We want to know, how does it compare with its alternate interior pair? So let's compare 4 with 5. To do that, we'll just spin the tracing paper around, and we look to see that angle 4 and 5 in fact line up. They look to be congruent. They look to be the same. The next angle pair is alternate exterior angles. So we're looking at 1 and 8 or 2 and 7. Let's do 1 and 8. Alright, there's angle 1. Let's compare it with angle 8. So moving it down, rotating the paper. Angle 1 fits right on top of angle 8. They appear to be congruent. So we've just had 3 pairs of angles turn out to be congruent when we made that one change. When we went from non-parallel lines, those angle pairs existed but they didn't have any special features, to now having parallel lines, those angle pairs exist and now they do have a special feature. So on that next page, page 3, we're just going to jot down our first few observations. So where it says step 3, compare the corresponding angles, we saw that those corresponding angles are congruent. When we compared the alternate interior angle pair, we saw that those angles were congruent. And then when we compared the alternate exterior angle pair, we saw that those angles were congruent. Alright, so we've compared 3 out of the 4. Here's the 4th one. Now let's look at the consecutive interior pair. And so again, I have to go back to the diagram on the previous page. Let's find a pair of consecutive interior angles. So 3 and 5 are good ones. Let's look at those. Alright, so here's angle 3. We want to know, are they congruent? Alright, so again, we'll move it over here and line up the vertices, and you can see they are not congruent. So that's kind of interesting. We had this trend going where each of these angle pairs were congruent, congruent, congruent. We get to this 4th one of consecutive interior angles, and they are not congruent. So that's kind of the exception to the rule that we're seeing so far. However, they may not be congruent, but maybe there's something else. Could we put them next to each other and form a straight line? Are they a linear pair? So let me go back to that diagram. Again, we're looking at angles 3 and 5. I already traced angle 3. We said angle 3 was not the same size as angle 5. 5 was much too bigger. But could we put them next to each other? So here's angle 3. Here's angle 5, so that they share a common vertex and a common side. Do they form a straight line? Yes, they are a linear pair. So it turns out that 3 and 5 are not the same size, but they are forming a pair of supplementary angles. So when the question is, for step 6 on the next page, do the consecutive angles form a linear pair? The answer is yes, and what we're really saying is that they are supplementary. So that's going to lead us now to these summaries. What you see below is kind of a summary of what we just saw, and how we're going to phrase this in an if-then statement to use on our proofs. Alright, so here we have the corresponding angles postulate. You can see that this is a postulate, the rest happen to be theorems. This is a postulate that says if there are two parallel lines cut by a transversal, then the pairs of corresponding angles are, and again they're just giving us one example of a pair of corresponding angles, but we learned that they are going to be congruent. Alright, so they are congruent. Now that only works if we have parallel lines. If those lines are not parallel, then our angles are not congruent. So how would we phrase that in a simple way as an if-then statement? We're going to abbreviate it and use symbols. Remember, this is the symbol for parallel lines. So if parallel lines, comma, then corresponding, and I'm just abbreviating it as angles congruent. Corresponding angles are congruent. The alternate interior angles theorem says if two parallel lines are cut by a transversal, then the pairs of alternate interior angles are congruent. So let's abbreviate that by saying if parallel lines, then, and I'm abbreviating this just using the first three letters. So alternate is just ALT, interior is INT, there's my angle symbol, and there's the congruent symbol. So it reads as if parallel lines, then alternate interior angles are congruent. For the third pattern, the alternate exterior angles theorem says if two parallel lines are cut by a transversal, then the pairs of alternate exterior angles are congruent. Again, let's abbreviate that by saying if parallel lines, then alternate exterior angles are congruent. This last one again is the exception. When we were looking at the pattern in our diagram, we saw that these consecutive interior angles are not congruent. They are going to be supplementary instead. So watch out. This is the one that's different. If two parallel lines are cut by a transversal, then the pairs of consecutive interior angles are supplementary. So we can't just mark up the diagram the way we had done before. We can't just put arcs in there because that would communicate they're the same size, and they're not the same size. So we would abbreviate this by saying if parallel lines, then consecutive, and I'll abbreviate it like this, consec, interior is INT, angles, and then SUPP for supplementary. Consecutive interior angles are supplementary. Those are the big ideas for this lesson. But we have just a little bit more on the final page as we take a look at an idea relating to parallel and perpendicular lines. So just flip that over, and we're going to finish up with these two, the parallel postulate and the perpendicular postulate. Now before we get to the diagram, that's kind of the diagram after we've figured things out, but let's kind of back up a step. Let's pretend you have one line and one point that is not on the line. Pretend this is the question, and I'm posing to you this puzzle. I want you to draw a line through point P. Well, at this point we could draw it anyway. We could draw it here, we could draw it here, right? We could draw lots of lines through point P. But I want you to draw a line through point P that is parallel to the original line. And the question is, how many could you draw? Meaning, how many unique lines could you draw that go through a point not on the line that will be parallel to the line? And while there's an infinite number of potential lines that could be drawn through point P, only one of them will be parallel. Only one of them will be parallel. And that's what you see here in the diagram. They're giving you the end result. They're saying there's only one possible line through a point that could be parallel to a given line. That's the parallel postulate. If there's a line and a point not on the line, then there is exactly one line. Exactly one line through the point parallel to the given line. So we say exactly one line, meaning no more, no less, and it is in fact required that we have precisely one line. It's almost the same now with the perpendicular postulate. If I give you one line and one point not on the line, how many lines would there be going through point P that is perpendicular to line L? So again, there's lots of possible lines that could be drawn through point P, but there's only one that would be perpendicular. And that's what you see in the diagram on the right-hand side. So again, the wording is very similar. If there is a line and a point not on the line, then there is exactly one line through the point perpendicular to the given line. And that's it for today.